starts now. So now I will continue with my welcoming. So, dear colleagues, I have the pleasure to welcome you on the behalf of the AIZ TVET Academy to our TVET Academy Learning Nugget on the 21st century technology skills. I'm delighted to welcome such a large number of interested colleagues to this event. Even I assume some terms of the topic might be a little unclear to you, as it also was to me before I started to learn about this technologies and possibilities that we have nowadays in our digitalized world. Lifelong learning never stops, and sharing is caring. So therefore, we present and want to introduce to you the topic of the session today, which is using affordable hardware in teacher training and TVET, use cases of single board computers, Raspberry Pi and Arduino. My colleague Mitilan and me are responsible for this topic of digitalization and TVET in our division. We are working on offers for our colleagues in the projects and their partners to develop key competences for the 21st century. To gain those competences, we need adequate technologies and tools. Therefore, we invited Hannes Tegelbeckers, a research assistant at the University in Magdeburg, our UNESCO UNIVOC partner, to introduce us to Raspberry Pi and Arduino, cheap but very effective and flexible single-board computers that can easily be used in educational settings and also applied in industry. He prepared 40 minutes of input, and we planned 15 minutes for questions from you, from the plenum. So feel free to write your questions already in the chat during the presentation. And after the presentation, we will have also chance for some oral questions. Now I hand over to Hannes, and we are curious to hear what you brought for us. You're muted, Hannes.
Fantastic start for digitalization skills. Can everybody see the screen? I shared already. Yes, should be all right. Yes, thank you, Olga, for the kind words, and thanks to the GIZ for inviting me on this topic. Just giving you a quick background. I started very early on within my family. My father was an IT technician with the German railway, and we got to know the Linux context, Linux-based operative systems and servers from very early on. And basically that stuck with me for life. And since my days at university, I was starting to tinker with different Linux distributions. And once the Raspberry Pi came out, I saw its capabilities. I started from the first one and then went up to see what each of the hardware options could bring to the table. And as you will find, they are quite intriguing and well loved all over the world. I think by now 46 million units are shipped from the Raspberry Pi alone. So that's why we concentrated on that. That's not to say that within the topic of physical computing that there aren't a lot of other options you could choose from. And I think there's even an alternate version for the Raspberry Pi called Banana Pi, which has a different outline and might be slightly cheaper. But we're gonna go stick with the Raspberry Pi and the Arduino for today. If there is, as this should be something which we develop over time, and I hope I can develop that for the GIZ within the next couple of years. What I would like to do is just like create a certain kind of interest, and then just like we can see how we can tailor different kind of hardware and software setups for the specific project within the GIZ universe. Okay, but I'm using primarily the Raspberry Pi and the Arduino, so I would like to run you through a couple of scenarios for the next 30 to 40 minutes. I would like to start with some frameworks on competencies and literacy to see where we're actually heading within the educational context, what we're trying to reach. Then I give you a quick overview of or like a quick comparison between the Raspberry Pi and the Arduino to see what they can do and what they can't do, and where you could use them and where you shouldn't use them. Then I go into some examples specifically in Guatemala, where I have an education project or a development project, which is specifically dealing with educational questions, where we are using actively the Raspberry Pi since years. I'm going to then talk about some projects we're doing at the Otto von Guericke University, where I'm training teachers and vocational education teachers. So for both school settings, we are training here in specific scenarios the teachers with the Raspberry Pi and sometimes the Arduino. And then I will make a leap and see and show you what might be possible in the future with some kind of remote settings, which is at the moment a collaboration with the Technical University Bergakademie Freiberg in Saxony, Germany. So let's get started. But first of all, I would like to know a bit who I'm talking to. So, or what kind of background knowledge you already bring to the table. Olga and Miti will pose some questions right now with a yes or no option. And what I would like you to do is basically give a thumbs up to the yes or the thumbs up to the no if the answer applies to you. So we're going to wait for that very quickly. There is going to be a couple of questions, just like posted rapidly. So just like, yeah, use your thumbs. Okay, we have some programming experience here, but not too much. All right, okay, already some people already use some Raspberry Pis, fantastic. You can wait for Olga to post the answers. So there'll always be a yes or no answer option, and you can just like click the thumbs up.
I posted all the 4 questions.
Okay.
Maybe you can just explain what LLM is for those who
like the large language models, basically the artificial intelligence setup the ChatGPT is based on. So they're kind of different LLMs around. We have, I think, Meta is using Llama or Llama, then BART for Microsoft based, and ChatGPT as a standalone option where Microsoft has a heavy influence in. But there are many others, like we have for programming. We have Claude, which is Claude at the moment, which is very stable on putting out very good code options. So yeah, but LLMs is the general term, large language models, how they're functioning with big data sets. Right. Okay, yes, we agree that there is that coding skills are essential for the 21st century. That's why we're here. That's why we're trying to see how we can integrate a bit of physical computing into the classroom. Some of you had the Raspberry Pi already in their hand, or the Arduino. Some of you have coding experience. Okay, and almost all of you played around with ChatGPT. So I'm trying to create a bridge here. How the coding skills I started to develop within the development sector, especially in Guatemala with some kids, while that might become very interesting specifically for using AI at the moment. All right, so we're moving on. So it's getting a bit dry now, a bit of theory, but just like we can't do anything without it. Just like to get a bit of orientation, targeted competencies and literacies. So there is no fixed set when we're talking about what we're trying to achieve with the Raspberry Pis. Like we have to have a framework in mind, what we actually want to do, because they are quite flexible in how, if we approach them, if we are using them, it is quite, they have a lot of options, what we could tackle. I'll come to that later, but I want you to have in mind that when we're talking about certain skill sets, that they are in very different areas of development, and we can't actually just mix them, right? So if we're trying to use an academic approach, when we're talking, for example, about computer literacy, this is a very narrow approach on the usage of the technology and its basic operations. So that's where, if you have the target of just developing computer literacy, then some of the physical computing computing units might be of interest to you. Others would just like fall out of the radar completely, because they just not easily applicable to a certain kind of teaching set you would like to implement into your classroom, right? So computer competencies, like if you would aim for that, just like this is a more a broader term, but just like it gets you into the arena of actually programming use, but as well as going for troubleshooting. So there is the sense of that the user's actually able to interact with a computer in a way, or with a technician in a way that he or she is already able to identify a certain kind of issues when they're running a program or doing a setup or running a setup, that they can help with the troubleshooting, and not just merely a user, but already just like invested into the program, the software, or the technical setup you're experimenting with, sorry. Then you have the straightforward programming competencies. That is very on top of the pyramid, I would say. So this is something we might aim for, but at a later stage, if it's about a pure programming, because then we don't necessarily need a physical computing unit. We could do that all on a laptop or a server or whatever, just like, or even on a mobile phone. So there's not necessarily a need for one of these smaller units to be bought. But there are some setups which might be interesting especially if you have younger target audiences, like say 16, 17, 18, to get some haptical and visual feedback. Digital literacy, this is a concept which is very broad and dips into the some ethical issues like data privacy, user privacy, and especially as well critical thinking. Just like, what about topics on mobbing, like the use of within social networks? It's all very important, but this is something where, for example, the physical computing unit might not be a wise choice. It might be. That's where we have to differentiate very, very thoroughly. And then we're coming to the computational thinking. So the computational thinking is one of the most interesting and intriguing part, because it not necessarily means that you should be able to code, but it means just like you have to start to think like a logical computer, and then just like adapt your problem solving to the logical grid you're working with when you're talking or working with a computer. So transferring that skill of your thought processes, your problem solving processes into a computer language, into a sort of algorithm. And there could be several steps for different kind of target audience age groups. You should start early. The British actually did that very early on. Computational thinking came up in 2006, and they are having a very efficient running how would you call it, program, which is started especially introducing as well Linux, Raspberry Pi over the years, and the Raspberry Pi is created in 2012. So they are on that topic since 10, 15 years already, and just like bringing that into their early education, into their classrooms. And there's a immense network and an immense community already working with open educational resources where there are projects, example projects you can use. So there's a lot going on there already, and there's a lot you could take in and use as a knowledge base for your projects, and then you just alter them, right? So just like to conclude with that slide is there is no comprehensive framework. You will, for now, if you want to be specific on what kind of competencies you actually try to train, you would have either try to pick and choose from the different concepts, or like you have to create something on your own, but that is like within the academic sector a bit tricky, let's say, to get into the actual theoretical discussions of what counts as what kind of skill sets, etc. Right? But this is not for the day. I just wanted you to have a quick think with me about the issue. We're going to go straight now into the actual hardware. So to show you what they're both of them are capable of. The Raspberry Pi itself is a very powerful unit. And those of you who already have some experience and maybe try to get their hands on them within the last 4 years, you would have experienced that it was impossible, because they are such powerful but still affordable units that a lot of people actually stack them, use them for crypto mining or whatever kind of high intensity calculation, because they were from the CPU very powerful and still very affordable compared to the alternative. So we have a 64-bit quad-core CPU, which means that you have multi-processing options. You can run like not just one program, you can run different programs. You can run a full operating system, most of the time Linux. You would use Linux, but there are options for Microsoft, for different kinds of server versions, you name it. So it's like and that is constantly developing. You have an Ethernet and Wi-Fi direct access point on the board, which means you can connect it to any kind of grid you have already available, which means if we're talking about Internet of Things, if you're talking about an option, a sandbox, or a server option within a industry context, then a Raspberry Pi is an easy solution to like get it into a network, into the network, and just like trial and error something you want to try out as an easy prototyping, and that's it. You have the option for to extend the Pi with the sensors and LEDs with the 40 GPIO pins. GPIO stands for General Purpose Input Output. So there's actually something you could add to the Pi. We're using it, like I come to the example later, but using it for just like real life experiences, or it's just like basically household appliances where you get some day-to-day feedback where the students are actually able to see the usefulness of the setup and the skill sets we're trying to teach. Arduino, in the contrast, is very specific in its task, and you can combine the two, which is also very helpful, to be honest, because it runs on much less power and has much less needs. But as you can see, there's only 16 megahertz of clock speed and an 8-bit architecture on it. You run only simple tasks with reading LEDs and sensors. You only have a 32 kilobit flash and 2 kilobit RAM. So that's like the processor unit is very down to earth. But what it is doing is just like, if you give it a task, it's just like executing that task straightforward. All right, so that's an easy in out, and that can sometimes be with a Raspberry Pi a bit tricky as well. You just plug the Arduino into a Windows PC, into a Mac PC or whatever. You have your software, and just like you put the program on the Arduino, and it continues, and it runs and runs and runs. Right. So for simple robotics, etc., it might be a go-to option. But that's what I said. Just like we're just here to giving some specific like some ideas, and then we could talk about specific setups for each project you might have in mind. All right, so this where I want to talk a bit about how I got into the development work and in the education sector, specifically now in Guatemala. I lived there for 2 years, and within a very, very rural setting, one of the poorest areas in Guatemala, and we had a massive problem of access to, access to anything, to be fair. And the schooling there is from the 1st to 6th grade mandatory and financed by the state. But that doesn't mean that like the kids actually learn something. So we had to create something of a, let's say, an interest, like how we are like an idea. We had to have an idea how we create an interest from the kids to actually show that learning means something and that learning can be fun. So we founded Lichutam Guatemala. It's like, so it exists in Guatemala, and we have a German association. And we started to play around with different ideas to help the school getting in touch with basically just different operative systems, but then in the end, just like as well, trying to access different kinds of online materials they can use to add to their existing schooling materials to improve the actual quality. So we started with used laptops, which were running Linux, and specifically the educational version of Ubuntu. Ubuntu, which is basically something, an operative system coming from South Africa, Linux-based Debian distribution, where one of the initiators said that like education or like material should be free of access, or like should be easily accessible and without of charge to the poorest. So here the idea of open educational resources came into mind, and that you actually would give out on the Ubuntu platform or the operative system, you will have a lot of software you can actually where you can change without infringing any kind of licenses. You can change the setup, you can change the code to adapt it to your specific project. So that's how we started. We started with Ubuntu, and then we bought in 2017, we bought Raspberry Pis for our first IT center. And then we went into the options of what you can actually do with the Raspberry Pi. So you have the Raspberry Pi as a standalone option. The standalone option, because it's fully functional, you add a screen, you add a keyboard, you add a mouse. You have the Wi-Fi and Ethernet connector, so you can easily connect it to the internet. And then we started with the digital literacy approach, so which we took from the laptops we did beforehand. So just getting used to how is a PC running, how do you switch it on and off, how do you start a program, etc. How do you write in Word, how do you write in Excel, etc. But then with the Linux approach, because the educational parts already bring a lot of games, a lot of programming games, a lot of interactive games for mathematics, for reading, writing. You could adapt that even to, we have a Mayan population which speaks Kikchi, so we were able to even adapt some of the games into the Kikchi language, which wasn't existing before, adding for word games some words, etc. So we could play around with that. And so the Raspberry Pi was here to, as a cheap standalone option. We bought every Raspberry Pi 3, which you've seen down there, what the kids are using, for 35 euros at the time. I mean, okay, you have the additional cost of the screen, etc. But for that, you couldn't buy any kind of alternative method, just like to have a fully functioning operative system running in this kind of centers. And they were actually, it's a very humid environment, but they were holding up until last year, where they started to fail, where we actually replaced them with Raspberry 4. So that is 2017, so like almost 5 to 6 years of running time, which was absolutely amazing. On top of that, you could use them with their GPIO pins for sensory and LED input. So you create little programming workshops where the kids actually see what their programming code is doing, that they can switch off something, they can read in information from a sensor, etc., and then start to explore automation and remote access. Remote access specifically because what we saw earlier, you could use it especially as a server, etc. So you can even tinker around with some kind of database where you put, I don't know, pictures, some data sets from a sensor, and then try to read them out to different PCs. This was then, that was the second part once we had the Raspberry Pis actually in the center and we stopped using the laptops. And then further on, we started to using robotics. That's where the Arduino came into play, because mounting the Raspberry Pi on a preset robot wasn't as easy. That there are what is the sets you can buy where you can add a Raspberry Pi to a robot, but I would say from experience, an Arduino for this purpose is much easier because it's easier to actually arrange the sensor in and outputs and the movements. So for the programming with the robotics, here we used Arduino, and that was a great success on behalf of the how the kids engaged with the robots. So building up on this success, when 2017 we had our first IT center. Right now we are running 3 of them and almost autonomously. So what the youth in the area did is like they took charge and they got into how to administrate Linux, and it's not as easy. I mean, but they got used to it. We had internet access, so you have a lot of community help, worldwide community help, because there's a lot of stuff going on within the educational sector. We had a lot of projects. Like I said, we already replaced the 3s with Raspberry Pi 4 based on local demand, because they were actually becoming too weak for the input or for the activities they wanted to do. And then we upgraded some with JoyPis, which is a pre-set-up board where you actually access some different sensors and output variations. And that's focusing more on the programming, and that's from an electrotechnical point of view. But just like this is the next step into the vocational education part. And then we started to have a request for drone training, and this is because the farms are already using some kind of GPS guided drones and stuff like that. So like they automating some of their processes in the area. And again, you're talking about one of the poorest area in Guatemala, but still they have to catch up with the demands. And right now the drone pilots and the programmers are coming from the city, but the local population is seeing that there's something interesting to be learned here, and just like some interesting competencies to be gained. And we do have active requests for some trainings. And what we are trying to do is getting AI on top of that as well. We saw earlier you can use the Raspberry Pi for an AI learning opportunity, and you actually can program them to like deal with different kind of data. So we're trying to combine the drones and the AI experience somehow to create some experimental education experiences with the youth. But this is like, that's something we're on right now. Okay, speeding up a bit. Teacher education. So basically, what we're doing at university is you saw the 5 competencies I introduced to you before. So we're showing that in every semester we make sure that we have some kind of literacy or competency outline in place, so they can gradually build up, and that is not going to be a shock when they have their first code in their face when they're actually trying to write their bachelor's or master's. So then they are encouraged, after building up, they have access to in different seminars to the Arduino, to the Raspberry Pi, to some Linux examples, etc. And once they write their bachelor or master thesis, they're encouraged to basically take some projects already existing, and we're not trying to overdo it, but just like some already existing projects from the community, and then adapt it to their school outline. So we're talking about vocational education teachers and secondary teachers, and they would choose their class, what they would trial it with, and basically write the full lesson plan, create the setup, create the programming, and then just like go from there to see if it experimentally actually works with the kids or not. We have some, like in this example, which I brought you here, is like we have a watering system, a water tutorial, which you find easily in the internet. There are different kind of examples with YouTube videos or what have you not, and you can have what you're learning is different kind of setups and calibrations with different kinds of sensors or motors you have in the respective project. You always can adjust that and scale it up, how complex you want it to make. That's always an option. And you can adapt it to any kind of scenario. So these are always the plus things we have in mind and we're actually using. So if we have one master thesis and there's something to be added on, then the next master thesis can just like work on top of that and just like alter the system without too much effort. We are started to use for program development or code development, started to use something like GitHub or SourceForge, which I would encourage you to do, because then just like a lot of people could actually contribute to your code and to your project examples. Within the vocational education sector, where we're trying to do something very specific because we had a demand from the electrotechnical department, and this is trying to bridge the gap, the funding gap between the vocational education schools and the industry. As you know, we are on a dual system, so we have the industry where our trainees are going and have some work experience, and then they come back to the vocational school. And they find often that the material or the material they have access to, or the software they have access to, is not the same as in the industry they're working. So for some of these examples, we started to find solutions with the Raspberry Pi. So you see here a programmable logic controller on the industry standard. So you could use that in industry context. You could use the Raspberry Pi as well as a gateway, as a server, what have you not. And there are specific examples, especially for the sandbox environments you could use, where you have trainees actually try something out first in the sandbox. And if everything goes right and to plan, then you can just like adapt that to the actual industrial example, which is basically another version of how you clone your or like a digital twin of some setups, but then would it be an open source version? And last but not least, what we do on top of that right now, and that this is in trial, we're starting to use remote labs and other options, like we had ChatGPT to diversify the approach and make it in some scenarios more accessible in the classroom. So first of all, what I want to present is the Address Labs platform based on GitHub in collaboration with our partners in Saxony, where you have a browser-based basically session, a learning session. A teacher can free of charge activate or start. And the only thing you need is basically a Raspberry Pi connected to your computer and a webcam. And what you could do is basically either create a setup, or you encourage your students to get some kind of hardware. You send your student, if it's a remote idea, send the hardware to your students, and then you can see if the setup works on their desktop. You can get a visual feedback via webcam. You can access their code directly, because they will start the session on their browser, and as long as the browser is running, they will have access to whatever is channeled through the PC and the Raspberry Pi. So here you can have laboratory experiences without the need of actually buying a specific set for every single student or a group of students. That is what we are trying to get into right now on the digital side. Furthermore, we have some interesting partners as well in Saxony who are applying that to some robotics. We saw the watering plant option earlier. Here you see a setup for a full-on robot who is not just watering, but taking pictures of the plants, evaluating via an AI if the plant needs a specific nutrition, a specific like needs water, or is sick, has a sickness or something like that, and then apply something automatically. So automating the process. This is as well on a low cost level. Again, it's within the industry sector, but on within the open educational resource universe. So like the idea behind this is always just like make this kind of setups accessible, but be able to scale it up to the industry level. And something which comes out last but not least out of the coding environment is that because we started to give them access to code and they saw something like that, now with the large language models, if you started to actually started prompting, you find that a lot of this prompting is, in a sense, a very weak form of coding. So you have to think about how do you address your topic, your problem, how do you just like give the AI a certain frame for that, and just like how do you actually try to define your solution. So you have to think a lot for the AI if you want to have a good output. And this is where the first access to coding and having been able to code just experimentally, seeing that on the playground, on the Linux playground, and then just like starting to adapt that now with the power of AI, we can see that because like let's use the ChatGPT example. ChatGPT is very strong and has a Python encoder as well already integrated. So whatever kind of data set you run into ChatGPT, it gives you a fully functioning Python code already out. Python is the go-to option for any kind of Linux system as well. So you have something here in common. And because this is such a powerful language, there's a lot of opportunity for having the power of code at your hands, at your peril, but still being able to just like, but not having to go through the full training. I always say having a ChatGPT support might be to having a bachelor informatics students at your side, and that is always a helpful thing if you talk about code. All right, that was the shortened input. I'm very good on time, I have to say. I wanted to present to you. We did this to actually promote a course, an introduction to Raspberry Pi in TVET Teaching. I would like to give on the 19th of September. So if you found this is something you might be interested in and you want to get to know the basics, then you're absolutely welcome. I'd be happy to apply some kind of project request or something like that to try to implement that into the session if it fits and I can do it. So yeah, keep that in mind. And the second thing I would like to say is, because Olga mentioned the GIZ and the Otto von Guericke University and the Fraunhofer, we are together the UNESCO Univox Center here in Magdeburg for sustainable TVET. We are planning an expert meeting on AI and TVET, and we will talk about some of these aspects I mentioned today as well, more on the AI level. But if you're interested in that kind of development, then you're absolutely welcome to join us on the 17th to 19th of February next year. That should be it from my side. You will find my contact details in the slides. If not, feel free to contact Miti and Olga for any kind of questions. And right now, I think I'll take some questions from you, and I hope there will be plenty. Thank you. Thank you, Hannes. Yeah, you're really good in time. I know you a little bit longer, so I know that it was, I expected you to need a few more minutes, but there's enough time for the questions.
By now, I see that in the chat are no questions written down. I know and I see that this is also, let's say, a heavy topic because it has also a lot of information on like technologies and a lot of, infos on like technological stuff. But, and I have to admit that I do not understand everything completely, but that's the reason why we have you here, Hannes. But what I know and what I understand is that we need to progress and process on the technologies and the tools that we are using to gain the competences that we need for the 21st century. So I would invite people to ask questions, to comment on your presentation. If there are no questions, then I prepared some. But I saw that there were some raising hands now and then. I don't know if they mixed them up with the clapping, but if there's anyone who wants to ask a question, please raise your hands now. Hannes,
If there are no questions for now, it's like what might have not got through is the importance of why we would use an actually physical computational unit to why would you make the effort to do that in comparison to just like start coding or just like get the kids in front of a laptop and do that stuff. And what is important is just like that with the experience of actually having to run specific hardware and just like having to set it up, this is invaluable for any kind of professional setting, right? And as well, if you start that from a younger age, because the Raspberry Pi or the Arduino, they are very flexible, you will create very early on specific feedback and experiences which will link to coding, and coding can be perceived as very dry. But if you can create projects with real life examples, then you might ignite some kind of interest within a world where, especially within our industrialized world for now, just like we struggle to find people within the STEM sector, and we're trying to create this kind of spark of just like, look, automation can be fun, automation is interesting, or sensory readings can be very fantastic if it's your houseplant or something like that. So try out your own project. So there is something a physical computing unit can give you, which a normal digitalized virtual version cannot. And that is just like having the computer in your hand, having to deal with it, having to deal with the problems and the setups, and just like getting the success in your hand, basically. Right.
We have a question from Joshua. He asks, can our students use Raspberry Pi without prior programming experience?
Okay, so yes, and what we do is quite intriguing in a sense that we basically reverse the whole thing. When we have the first access, you can easily use the Raspberry Pi as a standalone, fully functioning computer with Word and Excel, etc. But if you want to get them basically access to coding on a very low level, then you are able to just basically play some of the games which are on the Raspberry Pi, and then look into the code, into the Python code, and say, look, here's a code. We did this with Tetris, and I can't remember the other game we used, I think Snake. And then you see in the code the shapes, the timings, the structure, where's the coloring, etc. And you play the game, and they see this is a square shaped blue, and then it's like, where do I read blue? Where do I see a square? And then they interact with the code and start to see that code is sectioned. They start to read, and they intrigued in like how it work. And there's a lot of bug fixing if they want to try to tinker with the code. But this is the first easy access to code without ever having touched code before. Is that answering your question, Joshua, or were you referring to something entirely different? fantastic.
Yeah,
Okay.
that's exactly it. Can I add one more to it?
Of course.
Yes. So how different is Raspberry Pi from the Arduino?
Yeah.
Or can you use both together? I mean, when you are developing your projects, things like that.
Yes.
And how
Yes.
can we bring this to the classroom?
Well, that's always the challenge, to be fair.
Exactly.
You can use them together. The Arduino uses a different programming language, and it has a specific setup, which is browser based, or you can have an application installed on a Windows, or even like Raspberry Pi is getting ahead. So you are able to use the Arduino directly with the Raspberry Pi without too much trouble. But it is a different user feeling. Let's say that. So if you would basically start to try to read sensor data or try to program LEDs and use the Arduino, you would use the Raspberry Pi only as an operative system, right? Which is basically then starting a browser or starting the app and then running the Arduino via the Raspberry Pi. In this sense, so the Arduino is the supporter of the Raspberry Pi, but you could use the Raspberry Pi as a standalone option for some of these specific settings. What you could do with an Arduino, and you could then do even more. So basically, you could make the Raspberry Pi a server or a database in the same time as running the project, and then just like do a lot with the data and the data evaluation of the specific project. So it is really just like, how do you have to think, what would you try to start with, and what would you try to do? What I would recommend, if you have really no experience whatsoever and you need a PC or something like that, start with the Raspberry Pi and go for digital literacy. Get them used to how to install an operative system, etc., and then go into some sort of coding and step by step go into sensory data, etc. If you want a pure experience on this is robotics, and I just want to have 10 hours of robotics and that's it. No digital literacy, anything like else. It's like pure programming skills, just for the 10 hours. Then you buy an Arduino, you say, this is a robot, here are the blocks. You can just like drag and drop. It's basically like a Lego system. I think a lot of you might have heard of Scratch or something similar, and or Lego M blocks. And you just basically have a graphical interface, and you just like arrange the blocks, and then the robot is driving, right? So that is for 10 hours, easy, low hurdles, not a lot of knowledge necessary, and an easy investment, right? But it's very, very specific investment.
Mm-hmm. Okay, so Hannes, maybe do you know about examples where Raspberry Pi or Arduino is used in the German TVET system or in some occupations? So what do they use it for?
So the problem is that you will not come across, like, it's still something where a lot of engineers are trying, like they are rapid prototyping something within the industry, but there is nothing they write a paper about or something like that. Mm-hmm. So what they're using is basically they're using the Raspberry Pi as if they're trying something out for a server, or they want to connect a specific item to a Internet of Things grid, or like a grid within the factory, right? Then they would use the Raspberry Pi, just connect it to whatever kind of sensor rapidly they want to use, and then they trial and error like how it's functioning, and then would go into, okay, what we actually need, is it working, and then go into an industry standard setup. All right, so it's a lot about experimental stuff, but that is for the actual manufacturing and production area. there is a lot of examples for some basically data servers or what have you not, where they just try and error something. And because the industry has to train students, because of the necessity, they are using that for their students as a cheap option, just like to train them on specific topics without running the risk of destroying actual hardware.
Mm-hmm. Okay, there is Joshua raising his hand. Joshua?
Yeah, so what are the cost elements for this Raspberry Pi? Because that's one getting the hardware and all those things.
Right. So
yeah, cost element.
It depends on how stable your power grid is. In Guatemala, we are running a battery because of the instability of the power grid, like a battery supported power supply system. So that would cost you, I think that's about €80. The battery is more expensive than the actual Raspberry Pi. Yeah, and if you start with the Raspberry Pi on the 2 gigabytes, you're talking about €60, €65 at the moment, I think. Depending on the fluctuation is still there on the prices, because I think they're still on high demand, and I think the Raspberry Pi 5 is coming out soon. But so prices might drop on the 4. So you have the €65 for the Raspberry Pi. Then you need a HDMI micro cable to whatever kind of screen you want to use. So that you probably have to use an adapter. You need a keyboard and a USB mouse or a Bluetooth mouse. Yeah, and then if you want to connect to internet, you obviously would need a router. So roughly, I think we paid per workstation about €250 at in Guatemala prices.
Okay. Then I would just ask a last question. We have 2 minutes left. Why do you think the Raspberry Pi is a suitable solution for our work at GIZ? What are the advantages?
Because it worked so well in the Guatemalan context. I think just like that here's the problem. Like if you have Windows or Google or Amazon, like if you're paying their licenses, you're training your people on something which you will always in your life pay licenses for, right? But if it's for a training basis and just to getting the basic knowledge, if you use the Raspberry Pi, the Linux approach, and that happened quite a lot because of the open source initiative and the open education resources, you're not paying less on the licenses, but you can adapt those knowledge and just create experts in your field, which then be able to create work opportunities, create basically software for specifically for the area, for the country you're working in, and try to basically adapt their skills to very specific needs. And you don't have to have like a Microsoft expert you're paying, a Google expert you're paying, just to be able to or ask them if they can write you code because of the license restrictions. Right. So this is a very powerful approach if it comes to emancipating yourself within the digital sector and creating opportunities on a low entry level. Right. I'm not saying that everything will work out, but Python, I mean, this language is so powerful that they are writing complete weather models on Python, so it is just to the highest area of statistical evaluation for television programs. So it's working. It's a skill you should not invest in too much from the monetary side, and the Raspberry Pi is exactly the solution why you can create that kind of skill set with a minimal effort in class.
Okay, thanks, Hannes. I think we used our hour very well. Thank you for your input. Thank you for your enthusiasm, for your examples.
Thanks for having me.
Yeah, I hope some of our colleagues are interested in also joining the course, enrolling in the course, and learn more about the Raspberry Pi and this single board computers. Yeah. Thank you everyone for listening, for joining us, and we hope to see you again at another session. Bye-bye.
Thank you. Bye.
Bye. Thank you.